Hi everyone, this is my video on the proof to the general our Arclength formula for a function or a relation, doesn't matter. We have, and we know this is, as we know, L is equal to the integral of root of 1 plus dy over dx whole square to dx. But why is that? And I want to share with you a proof, a very simple proof based on just an intuitive idea of summing lengths by using the Pythagoras theorem. So, if we start here, we have, I use a different color, I use blue. We have a function defined, let's just call it something like this. This is just a graph of the function. And if we think about it, for every small dx, so I'll zoom in so we can look at this carefully. For every small dx, we have a dy, so we have a little length here, dl, and we have a dy. And this length is based on this dy and dx. So if we think about it, we have this. We have a little triangle of dl, and it's a right angle triangle because dy and dx are perpendicular, being just the y-axis and x-axis. And here we can just use simple Pythagoras, that our dl square is equal to, I can write here, by Pythagoras, square is equal to dy square plus dx square, and this is actually all we need. And from here, we can find this formula. So we can find this formula quite easily, in fact. And what we can do is now we can just rearrange. So I'll just write here, because we know L is equal to integral dl, and that's what we need. So we need to find dl in terms of dx and dy over dx. So if we look at this triangle, we're assuming dl is linear for a very small dx. So we know as dy is equal to dy over dx as a linear equation times dx. And this may seem just trivial, but the idea behind it is quite strong, because it is the small change in x times the gradient, as it would be for a linear equation. So we can just use that here, and so we get dl square is equal to dy over dx times dx square plus dx square. So if I expand this, we get dl square is equal to dy over dx square dx square plus dx square, where dx, and it's important to remember that dx and dy are the small changes, of course. So we can just treat them as lengths. And, sorry, one second. So we can just do this here. dl square is equal to dx square times, and we just factor out dx here, and we get 1 plus dy over dx square. And then we can write here dl, mod of dl is equal to root of plus dy over dx. And of course, as dl greater than 0, we can just say the small length is just equal to 1 plus dy over dx square dx and hence we just substitute that in our formula here for length, which was L is equal to integral dl, so implies L is equal to integral root of 1 plus dy of dx square with respect to dx. And this is in fact our formula because dl was this. So we get at the end L is equal to the integral of root of 1 plus dy over dx square dx as the arc length formula for a generic function. So thank you for watching. I hope you enjoyed. If you liked the video, please don't forget to like, share, and subscribe. And I hope to see you next time.